discuss about the heat changes associated with chemical reactions. This is a lesson for grade 11, second term. Okay. Heat changes associated with chemical reactions. Okay. There are two instances given here. When sodium hydroxide dissolves in water, you can be understand that you will be observed that the temperature rises, and when ammonium chloride dissolves in water, we can be observed that temperature falls. What's the reason for two observations? When sodium hydroxide dissolves in water, temperature rises. When ammonium chloride dissolves in water, temperature falls. Okay, let's understand that. There are two types of reactions, thermal reactions. They are endothermic reactions and exothermic reactions. Okay, temperature falls because of the absorption of heat. Temperature falls because of the absorption of heat. Such reactions are called as endothermic reactions. If it is an endothermic reaction, we can observe that temperature falls. The given diagrams describes this incident. In an exothermic reaction, energy absorbed from the surroundings. As a result, the temperature of the surroundings drops, so we feel cool to our hands. So, when there is an endothermic reaction, the reactants absorb heat from the surrounding, so the temperature falls. Such reactions are called as endothermic reactions. Then, what is an exothermic reaction? When there is an exothermic reaction, the energy is released into the surrounding as heat. So, as a result, the temperature of the surrounding increases. Temperature rises because of the loss of heat. Temperature rises because of the loss of heat. Such reactions are called as exothermic reactions. So, when there is an exothermic reaction is happening, the temperature rises gradually. What's the reason for that? The reason is energy is released into the surrounding from reactants. So, such reactions are called as exothermic reactions. So, you'll understand that when there is an endothermic reaction, temperature falls. When there is an exothermic reaction, temperature rises. So, there are two types of thermal reactions, endothermic reactions and exothermic reactions. Okay, exothermic reactions. Reaction between dilute sulfuric acid and magnesium ribbon. This is an example given in your test book. So, when we insert a magnesium ribbon into a test tube which filled with dilute sulfuric acid, we can be seen that there are water bubbles are evolved from the magnesium ribbon. So, what is happening? When this reaction is happening, temperature rises. Temperature rises because this is an exothermic reaction. We feel a heat. So, what is the chemical equation when sulfuric acid and react with magnesium ribbon? Magnesium solid plus sulfuric H2SO4 aqueous. Then react products are magnesium sulfate aqueous. Then hydrogen gas. So, the air bubbles which evolve from the magnesium ribbon are hydrogen gas. We can be concluded that. So, by the way, we can write another chemical reaction, balance chemical equation for the reaction between dilute hydrochloric acid and magnesium ribbon. So let's try your own to create the balanced chemical equation for reaction between dilute hydrochloric acid and magnesium ribbon. Then what's happening? Magnesium solid plus HCl aqueous. The products are magnesium chloride MgCl2 aqueous plus hydrogen gas, the same gas here. So these two instances we feel a heat after reaction, so those reactions are exothermic reactions. Then we can build up we can create an energy diagram for exothermic reactions. When we are drawing an energy diagram, y-axis indicates energy, x-axis indicates the reaction reaction. So reactants, then we can draw a position for products, reactants and products. When an exothermic reaction is happening, the energy released to the environment. Then after releasing the energy, products contain low energy than reactants. So we draw reactants upper from the products. So in an energy diagram, reactants draw upper position and products draw a lower position. So then using an arrow to downward, we can indicate the energy gap. So energy released when during an exothermic reaction, so heat is increased. So there is an exercise for you. Create an energy diagram for reaction between sulfuric and magnesium. Reaction between sulfuric acid and magnesium. So when you are build up the energy diagram, reactants. What are the reactants? Sulfuric and magnesium. H2SO4 aqueous plus magnesium. Then products, magnesium sulfate aqueous plus hydrogen gas. So let's consider the instances for endothermic reactions. There is an example given in your textbook. The reaction between citric acid and sodium bicarbonate. Citric acid is lime juice. We can use lime juice for citric acid, and sodium bicarbonate is actually baking soda. So we react lime juice with baking soda. Then we feel a cool, so temperature falls. So this is an endothermic reaction. The energy diagram for endothermic reaction is like this. Energy of products are higher than reactants because they absorb heat from the environment. When endothermic reaction is happening, absorb energy from surrounding. So temperature falls. So after absorbing energy, products contain more energy than reactants. So energy diagram is like this. You can create an energy diagram for every endothermic reactions if you know the reactants and products are. Reactions plus heat, arrow, products. So this is the comparison between the energy diagrams of exothermic and endothermic reactions. Reactants, products, reactants, products. Then there is an activity in your syllabus. This is very useful because in examination sometimes they will ask about this practical. So determination of the heat change of the reaction between sodium hydroxide and HCl. Reaction between sodium hydroxide and HCl. This is sodium hydroxide is a base and HCl is an acid. Strong base and a strong acid. So when they are reacting together, we can determine the heat change of the reaction. Heat change. So materials require 50 cubic centimeters of 2 moles per cubic decimeter sodium hydroxide. 50 cubic centimeters of 2 moles per cubic decimeter hydrochloric acid. 100 cubic centimeters of 2 beakers of 100 cubic centimeter. A thermometer, a polystyrene cup, and a glass rod. This is the apparatus. This is the diagram which you have to create in this activity. So this is the method. Measure 50 cubic centimeter of sodium hydroxide solution and 50 cubic centimeters of hydrochloric acid solution separately to the 2 beakers using measuring cylinder. Using measuring cylinder, you have to measure 50 cubic centimeters of each solutions to 2 beakers. Then, with the thermometer, measure the initial temperatures of the solutions separately. We have to measure the initial temperature. And then let's assume that sodium hydroxide, the temperature of sodium hydroxide solution is 30 Celsius and the temperature of hydrochloric acid is 31 Celsius. So we have to calculate the initial temperature by using the mean value. Then 30 plus 31 then divided by 2. So the mean temperature is 30.5 cubic centimeters. If these two solutions have same temperature, no matter. If the separate temperatures, you have to calculate the mean temperature, initial temperature. Let's assume that it's T1. Then after measuring the temperature of the solution of the base, wash thermometer before using the temperature of the acid. So we have to clean the thermometer. Clean the thermometer after using. So then mix the two solutions in a polystyrene cup. Stir with a glass rod and record the maximum temperature T2 like this. In the separator we can be seen that using glass rod we should stir the solutions and measure the maximum temperature T2. Why we are using a polystyrene cup? We have to prevent the heat loss from the apparatus. So heat cannot go through the polystyrene cup, so we will use this. Then observation and calculation. What are the observations we have now? Initial temperature we know T1. Then the maximum temperature we have measured, that T2. So we can find out the temperature change. Then maximum temperature, let's assume it's 60 Celsius and initial temperature is 30 Celsius. So temperature change is 60 reduce 30, then 30 Celsius is the temperature change. Then we have to calculate the heat change using this special equation. Q equals mc theta. Q is temperature, Q is heat change, m mass, C specific heat capacity, theta temperature change. Specific heat capacity is a constant value for water. In this practical, we use the specific heat capacity of water, not HCl or sodium hydroxide. We assume that the specific heat capacity of both solutions are equals to specific heat capacity of water. It's an assume. So, calculation. Let's think the temperature change is 10 Celsius. So, we can add the values and Q, we can get 4200 joules. So, if you have to calculate some questions in examination, they always provide the specific heat capacity of water, or don't remind it. Okay. Assumptions. There are 3 assumptions in this practical. The entire quantity of heat of the reaction is used to raise the temperature of the solution. We assume that there is no heat loss. So the entire quantity of heat of the reaction is entirely used to raise the temperature of the solution. Then other assumption is specific heat capacity of the solution is equal to the water, that of the water. The density of the solution is equal that of water. It is another assumption. Density of water is 1 grams per cubic centimeter. No. Then related questions. What are the losses of heat during the experiment? Loss of heat to the surrounding, absorbed heat by the container. Those are the losses of heat. But we assume there is an assumption entire quantity of heat is used to raise the temperature. Then to minimize this error, what can be used for this experiment? A thermally insulated polystyrene cup. It is used for minimize the error that occurred after loss of heat to the environment. Then to keep the temperature uniform throughout the mixture, what can be done? During our experiment, we stir the solution thoroughly. So the mixture should be stirred well with a glass rod. Then examples for exothermic reactions. First one, burning fuels for running vehicles and operating machineries. Then there are various methods to prevent the extra heat then cause for damages for machineries. We use some oils, engine oils and carburetor in vehicles. We use water, we add water. Then what are the fuels we use for burning process to produce energy? Coal, biogas, firewood, methane, petrol, those are the burning fuels we use to produce energy for vehicles and operate machineries. Then other exothermic reactions, example, cellular respiration in live bodies, in our all cells, humans, in animals and also in plants or microorganisms. There is a process, metabolism. In cells, it is main metabolic reaction, it is cellular respiration. During cellular respiration, energy released to surrounding. The release of energy during cellular respiration indicated in this equation: glucose plus oxygen. Then products are carbon dioxide and water, energy released. So cellular respiration is an exothermic reaction. Another example, production of slaked lime, reaction of quick lime with water. When we are producing quick lime, we react slaked lime with water. So it is an exothermic reaction. Temperature is rises when during this reaction. So what are the examples for endothermic reaction? First one is photosynthesis. When photosynthesis is occurred in plants, the plant body is cooled due to photosynthesis, because carbon dioxide plus water absorb energy from sun and produce glucose and oxygen. Then there is an exercise. Write down the balanced chemical equation of photosynthesis with physical states. Write the word equation of photosynthesis. You can refer the page number 22 in your textbook to write a right answer. Endothermic reactions, another example, production of quick lime by combustion of calcium carbonate, limestone. We can produce quick lime after combustion of limestone. So this is a full explanation of the unit 8, grade 11 unit 8. So please refer that and write down the lesson. Okay, good luck.